So this video is a continuation of the previous video, which is a crash course on probability, and we're going to continue on with that topic. And in this video we're going to look at cards that are not mutually exclusive. We're going to look at expected value, we're going to look at Bernoulli trials, and we're going to look at whether a game is a good game to play based on its expected value. So in the last video we took a quick look at the probability of getting a card from a deck, and the odds there expressed in either fraction form or in decimal form. And now we can take a look at some slightly harder questions based on maybe if you were asked to get two cards from the deck. So in this one it says, what's the probability of when you draw two cards from a deck that you would get a queen or a king? A queen or a king. So actually if you were asked to draw one card, what's the probability would be a queen or a king? Well, the probability that you would draw a queen is 4 out of 52 because there's 4 queens in the deck. The probability that you would draw a king would also be 4 out of 52. And because they're looking for one or the other, you would add those two probabilities together. So you would get 8 over 52, which when simplified becomes 4 over, I'll do that in a second. Now this one, a queen and a king, slight difference here. If you draw two cards, you draw one and then you draw a second card, what's the probability that it would be a queen and a king? Well, the probability that the first card would be a queen is 4 over 52. The probability that if you then replace the queen in the deck, so there's still 52 cards to choose from, and that the next card you pick is a king, would also be 4 over 52. But to do it in that order, you would now multiply those fractions. So there's the difference. When it's and, you multiply. When it's or, you add. So when you multiply those, you end up with a huge fraction. Something along those lines. So the probability of that happening is quite slim. Now this again is slightly more difficult. This is when you're dealing with not mutually exclusive cards. So let's say you're asked the probability to find a queen or a red card. Well, let's work out the probability of each one happening first. The queen, of course, there's 4 of them, so the probability of drawing a queen is 4 over 52. The probability of drawing a red card, well, there's 26 red cards, so it's 26 over 52. Or means you add them, so you come to 30 over 52. But of course, there's a catch. When I asked for red cards, 2 of those red cards are 2 of the red queens. So I can't include red queens both here and here. I can't include them twice. So I need to remove the ones that I've included twice. I'm just going to include them here. So of these 26 red cards, I've already included 2 of them. So I need to take away those 2 from my answer. So the probability of that actually happening, that you would get a queen or a red card, is actually 28 over 52. I can't count the same cards twice. This next question is the very same thing. What's the probability of getting a king or a picture card? Well, the probability of getting a king is 4 over 52 because there's 4 kings in the deck. The probability of getting a picture card is 12 over 52 because there's 12 picture cards in the deck. Or means you add them. That's 16 over 52. But of course, ask yourself, have I included the same cards twice? Yes, I have. Kings are picture cards, so I can't include them here and here. So I need to remove them. I've counted them twice, so I need to take away that 4. So the probability of getting a king or a picture card is actually 12 over 52. This is known as when cards are not mutually exclusive, that they include each other. And just to be aware of it, always think when you've worked out the probability, have I counted the same cards in 2 different places? Now, Bernoulli trials. Bernoulli trials are the probability of a series of events happening in a particular order. So, for example, in this question here, Jess takes penalties. The probability of scoring a penalty for Jess is 4/5. So ordinarily over Jess's career, she scores 4 out of 5 penalties when she takes them. Now work out, if she takes 3 penalties, the probability that she scores all 3. Okay, for that to happen, what would need to happen in penalty 1? Well, she would need to score it. So she would need to score penalty 1. Now, what's the probability of that happening? 4/5. What would need to happen for penalty 2? She would need to score penalty 2. And of course, the probability of that happening is 4/5. We were told this in the question. What would happen in penalty 3? She would score it. So the probability of that happening is 4/5. Now, here's the thing. Here's Bernoulli trials. What's the probability of it happening in that order? Well, I multiply those probabilities by each other. I multiply 4/5, multiply by 4/5, multiply by 4/5. And I get 64/125. So that's the probability that she scores all 3 penalties. Slightly greater than half. Now what's the probability that she misses all 3 penalties? Well, what would need to happen in penalty 1 for that to happen? She would need to miss. Now what's the probability of her missing? Well, if the probability of her scoring is 4/5, the probability of her missing is 1/5. And that would need to happen for all 3 penalties for her to have missed all 3 penalties. So I write that probability down, and of course Bernoulli trials is asking what's the probability that happens in that order. I multiply them. The probability that she misses all 3 penalties is actually quite slim. It's 1/125. So that's very straightforward when it comes to Bernoulli trials. But of course it does get a little bit harder in a question like this. What's the probability that she scores only once? Now, you might think that that's straightforward. Let's think about it for a second. For her to score only once, let's say she scores the first penalty she takes. So this would be a score, this would be a miss, and this would be a miss. That would mean she would have scored only once. So the probability of scoring is 4/5, missing is 1/5, missing is 1/5. So the probability of that happening in that order is 4/125. But of course it could have happened in another order. She may have missed the first one and scored the second. So let's say she scores penalty 2. And in that situation, she would miss penalty 1, score penalty 2, and miss penalty 3. Now what's the probability of each individual event happening? Well, missing of course is 1/5, scoring is 4/5, missing is 1/5. What's the probability it happens in that particular order? We multiply them, and of course it also works out as 4/125. Now there is a third possibility that this could have happened, the order in which this could have happened. She may have scored only the last penalty and missed the first 2. So she would have missed penalty 1, missed penalty 2, and scored penalty 3. And of course the probability of each event on their own is written in there, and to do it in that order, the probability of it happening in that order, we multiply them. So there's 3 different ways that Jess could have scored only once. And to find the probability of that happening, we add those probabilities together to get 12/125. Now that's a harder one. And the next one is very similar. What's the probability that she scores twice? Now again, we need to list all the possible ways that that could happen. So for that to happen, what would happen? Penalty 1, penalty 2, penalty 3. Let's say she scores the first and the second penalty and she misses the third. that would mean the probability would be 4 over 5, 4 over 5, and a miss for penalty 3 is 1 over 5. And we multiply them to get our answer, which of course is 16 over 125. But it could have happened in another way. It could be that, let's say, she takes her 3 penalties, penalty 1, penalty 2, penalty 3, and she scores the second and the third one, and misses the first, which would mean the probability of penalty 1 being missed is 1 over 5. Score is 4 over 5 and 4 over 5 for penalty 3. And of course, in that order, we multiply them. We end up with the same fraction, 16 over 25. And then the very last way that it could have happened would be that in penalty 1, she scores, penalty 2, she misses, and penalty 3, she scores. So for penalty 1, she would have scored, missed penalty 2, scored penalty 3. And they're the 3 possible ways that Jess scores 2 penalties. Could have happened in any of those ways. And of course, the probability of it happening in that order or in that order, so we add those 3 probabilities together, and we get 48 over 125. So just be aware with Bernoulli trials, it can be straightforward when they give you a question that there's only one possible way it could happen, like question 2 here. She misses all 3. Well, there's only one way that could happen. Miss, miss, miss. Yeah? But there's also questions that could come up where it could happen in different orders. So, like for this one, for example, that she scores only once. Well, implied in that is an order. You know, that it could be a score, miss, miss, or it could be a miss, score, miss, or it could be a miss, miss, score. All of those are examples of where she scores only once. So you need to work out the probability of each one individually and then add those 3 probabilities together to get you the overall probability. And that's Bernoulli trials. Now, the last little thing we're going to look at is expected value if you play a game, a gambling game. So let's say this is a game, this little spinner wheel here, and if the ball or the arrow lands in each particular slot, let's say if it lands in this slot, you would win €5, or if it lands in that green slot, you would win €8, etc. Now, it costs €20 to play. Each time you spin, it costs €20. So the question is it a good game to play? Well, it might be, because look, you could win 25 here or even 25 here. So you need to work out the expected value of this game. Now, how do you do it? Well, you list the various winnings in one column. Then you establish the probability of getting each win. So the probability of winning this €5 here. Well, the probability is the angle in here is a right angle. So the probability expressed as a fraction is 90 degrees out of 360. The same for this 25 beneath it. The probability of winning that 25 is, well, it's 15 degrees, so it's 15 degrees out of 360. And so is the other €25 win. The €7 win is 60 degrees out of 360. The €5 is another 90 degrees out of 360. The €8 is 45 degrees out of 360. And the €8 is 45 degrees out of 360. So you work out the probability of each winning amount happening. And then to figure out the expected value, what you're doing is you multiply the winning by the probability of winning that amount. So you multiply those figures by each other. So you would multiply 5 by 90 over 360, and you would get an amount, you would get an amount, you would get an amount, etc. All of these come to various financial amounts. And then to establish if this is a good game to play, you would add all of these amounts together. And if they come to be greater than €20, if the amount is less than €20, it's not a good game to play. It has a negative expected value. It's costing you 20 and you're winning on average less than 20, so it's not a good game to play. Vice versa, if it's greater than 20, it's a good game to play.